This is section 2.1, linear inequalities in one variable. When we talk about inequalities, we're talking about things like less than. It could also be greater than, it could be less than or equal to, it can be greater than or equal to. I'm only going to write our properties using one of them, but they do apply to all of them. Okay. First thing we have is the addition property, which is also like subtraction for the same reasons it was in chapter 1. And what our property says is if we know that A is less than B, or any of these, then we can add the same thing to both sides of the inequality and it is still true. Basically, this is the same as the addition property for an equation. We can add or subtract the same number to both sides and we still have something that's true. The multiplication property, which is also for division, here's where things get a little bit different. If A is less than B and C is greater than 0, so that means C is a positive number, then we can multiply both sides of the inequality and our sign points the same way. It's still true. Okay? But if we know that A is less than B and C is a negative number, it's less than 0, then A times C is now greater than B times C. In other words, if you multiply or divide by a negative number, you have to flip the inequality sign around into the opposite direction. Now, just as an illustration why this might be true, we know, for example, that -2 is less than 5. Okay, let's multiply both sides by a 3. -2 times 3 is -6. 5 times 3 is 15, and if you notice here, I multiplied by a positive number, and my sign points the same way. Ignore that part right there. Okay, now let's do the same thing here, but this time we're going to multiply by a -3. -2 times -3 is 6. 5 times -3 is -15. Now, which of these is bigger? 6 is. So you can multiply by a negative, but it changes your sign around. This type of thing, that's what's happening every single time we multiply or divide by a negative. Okay, so let's talk about solving each inequality. We're going to write our answers in interval notation, which is going to be a requirement on all of these problems. And we'll talk about that as we go along. And then we're going to graph our solution on the given number line. Every single time we have an inequality in this course, we will be graphing and we will be shading. I always get asked, how do we know when we have to shade? If you have an inequality sign, you're shading. The reason for that is because we don't generally get one answer for these problems. We get infinite answers for these problems. So basically, like if I said that x is less than 4, what numbers could we put in for x? Well, we have infinite numbers that are less than 4, but not everything's less than 4. So the graphing helps us do that. Let's come to this problem. 5t plus 2 is greater than or equal to 52. Now what we want to do is we approach this the same way we would for an equation. We want to get our variable alone on one side. The only difference really is that we have to remember that if we multiply or divide by a negative, we have to flip the sign around. Everything else is the same. So I want to get 5t by itself first. So I'm going to subtract 2 from both sides. That gives me 5t is greater than or equal to 52 minus 2 would be 50. Now we need to divide both sides by a 5. And 5 is a positive number, so I don't have to flip a sign around or anything. And I get t is greater than or equal to 10. Okay, so we've done most of the work. We just don't have our answers in the right form yet. You're always going to be asked to graph, which is why I have a number line here, and you're going to be asked to do interval notation. When you're doing your homework on the computer, it always asks for the interval notation first. It will check that, and then it will bring up the graph for you. it is really a lot easier to do the graph first. Since you're going to have to do both every time, you may as well do them both on paper, and then you'll just enter your interval notation, and then you'll enter your graph. It asks for it in the opposite direction, okay? Basically, this is saying all my answers, every t-value that works in this inequality is larger than 10. The only number I must see on your number line is the number involved here. So I have to see a 10. You may want to, especially in the beginning, put in some other numbers to help you see which side is which. Okay. Now I'm going to put a symbol on the 10. I have to figure out which one. Now you may have learned in the past they used an open circle for some and they used a closed-in circle for others. This is old notation. We do not use this anymore. If you've never seen this before, don't worry about it. Okay, so how do we know what we're going to do? We are either going to be using parentheses or you're going to use a bracket by something, one direction or the other. Okay, the way we decide what goes on is if you have a greater than or a less than, you're going to use parentheses. If you have greater than or equal to or less than or equal to, you're going to use a bracket. Okay, so right here, this has an equal to on it, so that means my graph is going to have a bracket on it. I haven't decided which direction it faces yet, but I know it's going to have a bracket because it has an equal to. Okay, so now let's look at this. My numbers are supposed to be larger than 10. The numbers that are larger than 10 are over here. So my answer graph, I'm going to look at I'm going to have a bracket on it. And I said every time we have an inequality, we will be graphing and we will be shading. What you want to do is you want to shade everything that will work. And that goes up forever, right? This is the answer to my graph. It starts at 10 and everything that is shaded, any number value in this area, I could plug in up here and have it be true. So I could plug in 12.539 and it would work just because it's in that shaded area. Okay, so this is the graph. How do we do the interval notation? Interval notation, you want to describe the area that is shaded. Okay, what you always want to do is you want to put the left boundary, comma, the right boundary. Okay, so if I'm looking at what I have graphed here, on the left-hand side, I stop at 10, so my left boundary is 10, comma. My right boundary, well, this goes up forever, right? So since this continues to go up and it's going up in the positive direction, we use a positive infinity. Okay, now this is not part of your graph answer, but your infinities are over here and your negative infinity is over here. This goes to infinity in the negative direction, this goes to infinity in the positive direction. So my boundaries are 10 and then it goes up to infinity on the right. Okay. Now what symbol do we use on the 10? We use the same one we used on our graph. So this gets a bracket. Now what goes on the infinity? Infinities always get parentheses. If you have a negative infinity or a positive infinity, you're going to use a parentheses by it. Now we only worry about these when we're talking about the interval notation. We don't put those on the graph. Okay? So this is my answer in interval notation, and this is my answer as a graph.